Welcome back to Prep for Calc. What did we learn about yesterday? Quickly, just a high-level picture. Compound interest being discrete versus exponential growth being continuous, the big difference there between the two. Logarithms, change of base is on the bottom on the change of base formula. Is there anything else? Surely there is more stuff. Oh, rational expressions. Rational expressions are fractions in which both the numerator and denominator are polynomials. What is a polynomial? It's something with more than one term, an expression with more than one term, meaning in a simplified, you've got more than one term, so it's got to have like a variable, essentially. You can't just have all numbers, constants, because you can simplify that down to this a single monomial, right? Monomial, and that's not a polynomial. Okay. And then simplifying or doing square root multiplication. Square root multiplication, basically you just got to know that the square root of a times b equals the square root of a times the square root of b. All right. Change of base. Natural logs. All right. Natural logarithms is log base e. That's essentially it. All there is to know. It's also ln. Everything else is just normal log type stuff. All right. I think today what I'm gonna actually do. No, I'll continue doing what I'm doing and just doing one topic at a time for one question, then I'll go back and make my rounds again. I was gonna say I was gonna finish the logs and the trigs, and then get into the new topics for log and trig, but we'll just keep doing what we're doing. So I'll be back in a bit to recall what I learned. All right, so got clear with the rational expression. So a rational expression yesterday. I clicked on the wrong topic. I clicked on radical expression. That's why we were doing multiplication of square roots. Well, I was like, why does this have to do anything with rational expression? So today I actually was in rational expressions. So a rational expression, again, is an expression that can be expressed as a polynomial divided by a polynomial, like a fraction of two polynomials. A polynomial, it turns out that a number is a polynomial. A monomial apparently is a polynomial because you can write something like 1 plus 0 x to the first, something like that. That's a polynomial. So I believe that's how it is. So what is a polynomial? A polynomial is basically constant times variables, and the variables are two powers of whole numbers. I think that can be the whole number. Yes, that is including 0. So 0, 1, 2, 3, 4, 5, etc. 0 and positive integers. And then they're combined using addition, subtraction, or multiplication. That's how you get a polynomial. And a rational equation, this one's a little bit now iffy, but like yesterday, I just threw something against the wall, got a general idea of what a rational expression was, refined it further today, refined it with the polynomial. Rational equation, it probably, what I wrote down is it's an equation that contains one or more rational expressions, but if you have maybe a square root or a trig function or whatever else you might have in there, it might throw it off and make it not a rational expression anymore. But anyway, for now, we're just going to say it's an equation that includes one or more rational expressions. That's a rational equation. So we solved rational equations today. We simplified complex fractions without variables. So just like fraction added to a fraction divided by a fraction minus a fraction, something like that. I don't know why Alex decided that I don't know how to do that when I do know how to do that pretty well. I don't know. I don't feel like they even tested that, so it's a little strange getting these things that weren't tested, but they just like assume I don't know how to do it. So is what it is. Rational expressions, rational equations, and then inverse variation. I know what direct variation and inverse variation is. I do. I just forgot about the constant. So that was why I was having a trouble actually doing calculation because I forgot you have to solve for a k or a constant when you're saying um, x equals y. That's direct variation. X equals k over y. That is inverse variation. I was doing 1 over y. You can't assume a 1. You have to do k, then you have to solve for k. Now you have the proportionality constant, something along those lines, and then you can plug in what one of the x values or one of the y values and get the corresponding x or y value then. All right. Yeah, we're just ripping through all this stuff that I've learned in the past, but never really integrated that well or articulated that well. So it's cool. Good stuff. Guess I know more than I thought I did or realized because I can pick this stuff up pretty quickly. Anyway, talk to you tomorrow. See ya.